Okay, so we're going to talk about perfect square trinomials. Okay, so we're going to start off and we're going to look at these two binomials that are being squared, and we're going to use the distributive property to multiply. So when you see squared, you can't just square the terms. You have to think of what does it mean to square something. It means to take whatever you have and multiply it by itself. So a plus b squared is a plus b times a plus b. And now we're going to distribute. So a times a is a squared. A times b is a times b, and then b times a, we like to write alphabetical, so a, b again, and b times b is b squared. And if we simplify that, we have a squared plus 2ab plus b squared. So that is the factored form, or the distributive form of a plus b squared. Now let's do the same thing with a minus b squared. So again, we have a minus b times itself. If we distribute, we're going to get a squared minus ab, and then plus b squared. And if we simplify that, we get a squared minus 2ab plus b squared. And these are called perfect square trinomials. And if we say, why do we think we call them that? These two here in this format, when factored, will make perfect squares. Both factors will be exactly the same. Okay, so we're going to look at the problem below. In order to figure out perfect square trinomials, the following things must be true. The first term must be a perfect square. The last term must be a perfect square, right? Because we have a squared and b squared. And the middle term has to be 2 times the product of the square root of the first and last term. So 2 times the square root of a squared is a, and the square root of b squared is b. So 2 times a times b. So let's check this. Okay, so the first term must be a perfect square. So is x squared a perfect square? Yes. The last term must be a perfect square. Is 9 a perfect square? Yes. So that checks. The middle term must be the 2 times the product of these two numbers. So if we take x times 3 and then multiply by 2, we should get the middle term, which we do. So this is a perfect square. So let's check the next one. Square root of x squared is x. The square root of 4 is 2. So those are both perfect squares. If we multiply them together and multiply by 2, we get 4x. Is that the middle term? No. Okay, square root of the first term is 5x. Square root of the last term is 1. If we multiply this together times 2, do we get the middle term? Yes. Okay, so that's how you determine if something's a perfect square. So then how do you factor perfect squares? We're going to use the same idea. So to factor a perfect square, you're going to take the square root of the first term, and you're going to take the square root of the last term, and you're going to take the sign of the middle term, which is negative. Okay, so the square root of the first term, square root of the last term, sign of the middle term, then you put that in parentheses and you square it. And that's how you factor a perfect square. So let's look at the next problem. Factor this. So is 9 over 25 a perfect square? Yes, because the square root of 9 is 3, the square root of 25 is 5. Is this a perfect square trinomial? So let's check that out. We have first term is, the square root of first term is x. The square root of the last term is 3 over 5. And we multiply by 2 and we get x equals 6 over 5. We get 6 over 5x. Is that the middle term? Yes. Okay, so now we're going to use our factoring. Square root of the first term is x. The square root of the last term is 3 over 5. The sign of the middle term is negative, so we have x minus 3 over 5 squared. Let's look at another one. So this one here asked us to solve, so we're going to move the 64 to the other side. 9x squared minus 48x plus 64 equals 0. Remember, you're always setting equal to 0. So now we're going to do the same process. Square root of the first term, square root of the last term, multiply together times 2, and make sure you get the middle term. So I get 48x, so yes. If that's the case, then our answer is going to be the square root of the first term, square root of the last term, sine of the middle term squared equals 0. Now we have two factors, but they're the same. We have 3x minus 8, and we have it again. And if we solve that, we get 3x equals 8, and x would equal 8 divided by 3, or 8/3. We get the same answer twice. So when we get the same answer twice, we call the answer 8/3 multiplicity of 2. So it happens twice. We have the same answer twice. That's going to be important when we go graphing.